Hey everyone, I'm back with a final video here on L'Hopital's rule. This is the second day of notes on L'Hopital's rule, and I start by just saying that today, the difference between today and the first videos on this is that today we will be working with a different indeterminate form, infinity over infinity. Up until now with L'Hopital, we've been working with 0 over 0. So let's read this part right here before we get into the examples. It says, L'Hopital's rule also applies to quotients that lead to the indeterminate form infinity over infinity. And here's what it says. If f of x and g of x both approach infinity as x approaches a, then the limit as x approaches a of their quotient here is equal to the limit as x approaches a of f prime of x divided by g prime of x, provided the latter limit exists. So it's exactly the same as our first video, but be on the lookout for infinity over infinity. Now let me show you the beauty of this. Back in Unit 1, when we studied limits and continuity, I'm going to remind you of the old way of doing things, which some of you didn't like very much. The old way of doing things, well, when we had a limit like this, we always started by plugging infinity in. So we would do like 3 times infinity minus 2 divided by infinity plus 5. And the principle of dominance told us that the answer here was infinity over infinity. And that was undefined. So we went on. Do you remember what we did? We went on and we divided each term of the rational expression by the highest power of x in the denominator, which in this case is x. So our next step looked like this. 3x over x minus 2 over x divided by x over x plus 5 over x. Then we reduced, which became 3 minus 2 over x over 1 plus 5 over x. And then we, one more time, replugged infinity in for our x's, which gave us 3 minus 2 over infinity, divided by 1 plus 5 over infinity. These two went to 0. And so we were left with a final answer of 3. And some of you moaned and groaned your way through that. Now, with L'Hopital, once you get your indeterminate form, you will simply take the derivative of the top, which is 3, divided by the derivative of the bottom, which is 1. The limit as x approaches infinity of 3 over 1 is 3. That's 3. You have nowhere to plug in x, so you go with it. Done. Like that better? Thought you would. Let's go to example 2. We're just going to do L'Hopital for this one. So the limit is x. Okay, so let's plug it in. So this would give us the natural log of infinity divided by infinity. You might be saying, well, what the heck is the natural log of infinity? Well, we say that that's infinity. The reason is, what exponent should e be raised to result in infinity? Well, 2.718 raised to what power makes infinity? Well, really, really big powers. So take 2 to the raise it to the infinity and we'll be getting infinity. So we're going to call that the indeterminate form infinity over infinity. Because the bigger the exponent, the bigger the result. Okay. That's indeterminate. So now we will simply apply L'Hopital. All right, the derivative of ln of x is 1 over x. The derivative of x is 1. Plug your infinity back in, and you've got 1 over infinity divided by 1. 1 over infinity is 0, and 0 over 1 is 0. Done, finish, finito. That's all you need to know. We'll do some practice with this, but that's just another indeterminate form for L'Hopital's rule. Thanks for watching.